As with the counting rules, there are some basic probability relationships that we can conveniently use. As in the counting rules, they can be used without us having to actually write down long solutions. Similarly, we don't need to have knowledge of the probability of all the probabilities of all the events, and can instead just use these simple basic relationships. We will be looking at these concepts: the complement of an event, the union of two events, the intersection of two events, and so-called mutually exclusive events. What is the complement of an event? Here it will help to remember what you've learned about Venn diagrams from your high school math. The complement of an event A is just defined to be the event consisting of all sample points that are not in A. Formally, we designate the complement as A to the C. Consider this. The square, the sample space, consists of all sample points. The event A is just the sample points that are consistent with something we have defined, and they are all the points within the blue circle. So what is the complement? They will be all the points that are within the square S but are outside the circle A. What is the union of two events? It is just the event containing all sample points that are in A, or in B, or in both A and B. Mathematically, this is how we write it. The union of events is A union B. Consider the sample space. There are two events. Look at some points. Some points are in A and only in A. Some points are in B and only in B. And some points are in both A and B. What is the union? It's just both circles, A and B. Consider this: Bradley Investments. One event is Markley is profitable. Another event, Collins is profitable. What is the union? It is those sample points where Markley is profitable or Collins is profitable. This is an important point to note. When we are calculating unions, we are using OR. So as you will see, these are all the points where either Markley is profitable or Collins is profitable, or both. Consider, for instance, this 10 and 8. Markley is profitable, Collins is also profitable. Look at the second point, 10 and minus 2. Markley is profitable, Collins is not profitable. But because we want Markley is profitable or Collins is profitable, this falls within the union. And what is the probability, therefore, that Markley or Collins is profitable? You just add up the probabilities of each of the sample points. Hence, there is an 82% probability that Markley or Collins will be profitable. What is an intersection of two events? It is just the set of all sample points that are in both A and B. So this is an important point. The sample point has to be in A or in B. If it's only in A but not in B, then it doesn't count as an intersection. And if it's only in B but not in A, then it doesn't count as an intersection. This is the mathematical way to write the intersection. So look at the gray part. That is the intersection of A and B, because each point there is in both A and B. Consider this where the pointer is. That is a point that's in A. but it's not in B. Hence, it cannot be part of the intersection. So again, let's consider the case of intersection with Bradley Investments. What is the event M? Markley is profitable. Event C, Collins is profitable. What is the intersection? Markley and Collins are both profitable at the same time. So this is an important point to note. For the intersection, we use AND. So there are only two sample points where both are profitable. These are their probabilities. We add them up, and hence there is a 36% chance that both Markley and Collins will be profitable.